Now let us try to understand how to find the position of an element in the periodic table. If electronic configuration is given to us, we can very easily find the position of that element in the periodic table. If we write the electronic configuration and we see that the maximum value of n is 4, suppose, means the principal quantum number is 4, it means that element will belong to fourth period. Means if we write the electronic configuration, whatever maximum value of n is in that electronic configuration, that element will belong to that period. Similarly, we can very easily find out the block of the element. If last electron enters in the s subshell, it belongs to s block. If the last electron enters in p subshell, it belongs to p block. Similarly for d and f also. And let us take the example of s block elements, how we can identify the group of s block elements. We know that s orbital can have only 2 electrons. Maximum capacity of s orbital is only 2. It means it will either contain 1 electron or it will contain 2 electrons. If it contains 1 electron, it means that element belongs to alkali metal, group number 1. And if it contains 2 electrons, it means it belongs to alkaline earth metal, means group number 2. So this is the way to find out the position of s block elements, means they will belong to whether group number 1 or group number 2. Now let's come to the group number 13 to 18 or p block element. We know that this is the representation of periodic table. On the extreme left side we have s block elements, on extreme right side we have p block elements, and in between these two we have 10 d block elements, 10 groups of d block elements, which are known as transition elements. And lower in this we have f block elements, inner transition elements. Now let's come to the p block element. P block element, we know that if the electron enters in the p subshell, that element will belong to p block. Now how we will find out the group number of that element which belongs to p block? For that, if it contains p1, let us write the electronic configuration, let us write it is np1. It means it contains only p electron in, it contains only 1 electron in p subshell. It means that element will belong to 2 plus 10, means 2 elements in the s block, then 10 in the d block and 1 in the p block. It means 2 plus 10 is 12, plus 1 will be 13. If this is the electronic configuration, that element will belong to group number 13. If it is np6, it means that element will belong to group number 18. Means if it is this is the general electronic configuration, then we have to add 2 for s block elements, 10 for d block elements, and the number of electrons in p block will give us the, we will get the number of that element, means the group number of that element can very easily be obtained. Another example, if it is the electronic configuration np5, then for s we will add 2, for d we will add 10, and for 5, this is np5, it means plus 5. So it will give us 10, 2 plus 10 is 12, plus 5 is 17. So this will be the group number of this element, means whose outermost electronic configuration is np5. And whatever the value of n is, that will give us the period of that element. Now another, let us come to the topic d block element. Now how we will find out the electron group number of the element which belongs to d block? We know that after s in the periodic table, d blocks are arranged. It means 2 electrons or the 2 elements in s block, and after that the element will be in the d block. So whatever electrons are there in d orbital, we have to add that with 2 and we will get the group number of d block element. Now let us take the example. Suppose it is d2, nd2, it may be 3d2, it may be 4d2, but it is d2 means it contains 2 electrons in the d orbital or the d subshell. It means 2 plus 2 will give us 4. This is the group number of that element which belongs to d block. And next is, last is f block. We know that all the f block elements, they are located at this position, and Together they are written here, and in long form they are written here. These are 14 elements, and all these F block elements, they belong to group number 3. Period can be found out by the maximum value of n, and group for S can be obtained by number of electrons in the S. P can be obtained by adding 2 plus 10 and number of electrons in P subshell. For D, the group can be obtained by adding 2 plus number of electrons in D subshell, and for F, all the elements, they belong to third period. Example, suppose this is the electronic configuration of an element 1s2. This is 1, it means its period will be 1. This is the maximum value of n. This 2 means it first of all it is s block element because the electron is entering in s orbital. So it is s block element. 2 electrons are there, it means its group is 2, that is it is alkaline earth metal. Next is Ns2np4. Now as we know that if the outermost electron is entering in the p orbital or the p subshell, that element will belong to p block. So this element whose outermost electronic configuration is Ns2np4 and the value of n is given, it is 3, it means it belongs to period number 3, block p block, and period number 3, and group number will be, the rule will be applicable here, 2 plus 10 plus number of electrons in E, it means 2 plus 10 plus 4, it will make 16. So this is the group number of this element whose electronic configuration is this. Now let's take the example of one D block element. Outermost electronic configuration is this, n minus 1 D2 NS2, and n value of n is given, it is 4. Now if the value of n is 4, it means that the element will belong to period number 4. Electron is entering in the d orbital, it means it is d block element, and d, for finding the electron element in the group number of the d block element, the rule will be that you have to add 2 plus number of electrons in d. So that makes it 2 plus 2 is equal to 4. So its group will be 4. Now the last F block element, let us take the example of the electronic configuration is n minus 2 F7 n minus 1 D1 NS2. As you know that outermost electron is entering in F orbital, then it means it belongs to F block. And you know that all the F block elements, they belong to group number 3, so it will belong to group number 3. And the period will be the maximum value of n, it is given, it is 7, it means this element belongs to group number, this element belongs to period number 7. This is the way to find out the position of any element in the periodic table, means block, group and period.